Welcome back, dear students of class 12. Today we are going to begin with a new chapter, and the chapter is organic compounds containing nitrogen. And under this particular topic there are different groups of compounds, and today we are going to discuss about amines. So about amines, you know how to name them according to IPSC, that is their nomenclature. And so we will be starting with methods of preparation in today's class. So amines are those compounds which contain functional group as NH2. So whenever this NH2 group is present in a compound, okay, alkyl group or it could be aryl group, so to that particular group, if NH2 group is attached, then those categories of compounds are known as amines. So amines can be prepared by different methods. Okay, so we are going to discuss them one by one. The first one is from alkyl halide. Preparation of amines from alkyl halides. So, when alkyl halides are heated with ethanolic solution of ammonia at 100 degrees centigrade, a mixture of amines will be produced, like first degree amine, second degree amine, third degree amine, and quaternary amine. So let's write the reaction. That would make this more clear. So alkyl halide in general is represented by Rx. So whenever it is treated with ammonia is NH3. So in presence of, whenever it is heated at 100 degrees centigrade, then the reaction between this alkyl halide and ammonia takes place. Now this ammonia, for better understanding, can be written as NH2H. So this is NH3 itself. So how the reaction takes place is this HX will be eliminated from this particular compound, that is minus HX, and this R group now will be attached to this nitrogen. So we have RNH2. So this is NH2 group is attached to only one carbon containing group, therefore this is first degree amine. This is first degree amine. Now similarly, when this first degree amine is further treated with alkyl halide, that is Rx. Okay, now what will happen? As here in this first step, this H and X has eliminated. Here also one H from here and X will be eliminated as HX. So this R now will be bonded with this nitrogen. Therefore we have R2NH. Okay, this is second degree amine. Now in the next step, since it has this replaceable hydrogen, this further reacts with alkyl halide. Now here also this HX will be eliminated. Don't forget this reaction takes place at 100 degrees centigrade. So what will happen? This R will be going and getting attached to this nitrogen. Therefore we have now R2 plus 1 is 3 and here we have minus HX. You know nitrogen contains lone pair of electron. Yes. Now here this is third degree amine. This lone pair of amine, this lone pair over nitrogen now reacts with further one molecule of Rx, that is alkyl halide. Now halogen is more electronegative. This is delta negative. This is delta positive. Obviously this lone pair of electron is like negatively charged. Therefore now this will be bonded with this R and this halogen leaves. Now this R3 plus 1 R is how much? R4N. And since nitrogen has lost its electron, therefore it is a positive sign here. And here what is the byproduct? This is N plus. Now since this X has left as minus, now this will come and stay near the positive charge. Now this is our quaternary salt. Okay, this is quaternary salt. So this method, in this method we saw from alkyl halide we get first degree alkyl halide as well as second degree alkyl halide, third degree and fourth degree, that is quaternary salt. So at the end of the reaction, what we obtain? We obtain a mixture of product. Now, since this mixture of this first degree, second degree, third degree and quaternary are very difficult to separate, are very difficult to be separated, therefore this method is not that convenient for preparation of one particular alkyl halide. Okay? Now this reaction is also known as Hofmann ammonolysis. This reaction is also known as what? Hofmann ammonolysis. Okay? So this was our first method. Now second method, it can be prepared from nitro compounds. So the second method for the preparation of amines is from nitro compounds. From nitro compounds by reduction. Okay, now see, in this method, amines can be prepared from nitro compounds by reduction. So both aliphatic as well as aromatic amines can be prepared by reduction of corresponding nitro compounds by treating them with certain reducing agents. And please note it down. What are the reducing agents used here? The reducing agents used here are reducing agents used in this particular reduction of nitro compounds are Sn in presence of HCl, tin in presence of HCl. This is one reducing condition. The second one is Fe in presence of HCl. Similarly, you know it very well, even lithium aluminum hydride can be used as reducing agent. Okay, so these three and one more, that is hydrogen in presence of either nickel, platinum or palladium. So these four are reducing condition for nitro compounds. So let's try the reaction here. See, NO2. Now this is nitro compound, NO2 group is there. Okay. Now whenever this reacts in presence of any one of these reducing agents, then they will be reduced to amines, RNH2. Look here. Here hydrogen has come in place of oxygen. So from the basic definition of reduction, removal of oxygen is what? It's reduction, or addition of hydrogen is what? Addition of hydrogen is also reduction. So any one of these reagents can be used for this particular reduction. Now here, I'll be writing only one reagent, that is HCl, but you can use any one of them for this reducing condition. Now this condition produces nascent hydrogen. Okay, and how many are used here? Here, 6 atoms of nascent hydrogens are used for reduction of this nitro compound to amines. Okay, so hope this reaction is clear. Now let's discuss another method of preparation, and that is from cyanides or nitrites. The next method of preparation is by reduction of nitriles, or you can write from cyanides by method of reduction. Cyanides, you know, they are also known as nitriles. Okay, cyanides is the common way of naming them, and here nitriles is the IUPAC way of naming them. So here these nitriles are those compounds which contain C triple bond and group. And don't forget, this carbon is bonded to the alkyl group. Had it been this nitrogen here and carbon here, that would be isocyanate. I have already taught you this part. Okay, so here in this method also, see, cyanides, amines can be prepared from cyanides by method of reduction. So here also we need to know what are the reducing agents used. Here the reducing agents that are commonly used are lithium aluminium hydride or sodium in ethanol, that is C2H5OH. So this any one reducing agent can be used for this particular reduction of cyanide. Here also they will produce nascent hydrogen, and as a result of that, this cyanide will be reduced to amines. Look here, you have C and N only, and in the product you have CH2, means 2 hydrogens are added here and 2 more hydrogens are added here. Therefore it's reduction. In total, how many hydrogens are added? 4. Therefore we need 4 nascent hydrogen for this particular reaction to take place. Okay, hope this is very clear, because this is very simple reaction. Now, if this particular reaction, okay, this particular reaction takes place in presence of sodium in ethanol, then this particular reaction is known as Mendel's reaction. Okay, so it has to do with this reason. If this is present in this particular reduction, then that is known as Mendel's reaction. Okay. So if you want to take one particular example with aromatic ring, and let's do it. So we have said C triple bond N. So whenever it is reduced in presence of either lithium aluminium hydride or sodium in ethanol, okay, lithium aluminium hydride or sodium in ethanol C2H5OH, then what will happen? 2 hydrogen will be added to this carbon and 2 hydrogen will be added to this nitrogen. As a result, we get this compound CH2NH2, and the name of this compound is benzylamine. This group is what? Benzyl group. Therefore, this is benzyl, and NH2 is what? Amine. Therefore, this is benzylamine, and that is its common name. And its IUPAC name would be, this is one carbon containing, this chain contains one carbon, and one of the hydrogen is substituted with what? Phenyl group. Therefore, it is phenyl methyl amine. Okay, one carbon is for what? Methyl group. So phenyl methyl amine. Now let's discuss the next method of preparation, and this is very, very important. That is Hofmann degradation reaction or Hofmann bromide reaction. Now this is our fourth method of preparation by Hofmann's bromide reaction. Okay, and this reaction is very important. Okay, and in our previous video we had discussed about this ascent and descent of this carboxylic series, and there we have used it. Okay, so here in this method also, first degree amines can be prepared from corresponding first degree amines. Please look at it carefully. Okay, so let's begin with a general reaction first. So let's take aliphatic ring CH3 C double bond O NH2. So this is amide group. This CONH2 is what? Amide group. Now see, this NH2, if it was attached directly to alkyl group or aryl group, then that would be amines or amines. Since this NH2 now is attached to C double bond O, please don't make mistake. This is amide. Okay, this group is known as amide. Now, whenever first degree amides are treated with bromine and in presence of KOH, then what is the product? Here, in this particular reaction, this C double bond O will be eliminated from this particular compound. It will go out. Therefore, this nitrogen now will be attached to this CH3 group, CH3, NH2, and this is here, it is amine. And since this nitrogen is attached to only one carbon, therefore, this is first degree amine. And what are the byproducts? The byproducts are potassium carbonate plus KBr plus water molecule. Okay, so we have three byproducts, and our main product is what? First degree amine. Don't forget here, in this reaction, the carbon chain. See, here we have two carbons, and the product contains only one carbon. Therefore, this reaction is used for descent of series, not ascent but descent, in going from higher carbon number to lower carbon number. Okay, and we had used it in our previous descent of carboxylic series. Please check it. Now, the final method of preparation is a very interesting one. Let's do that. And please, while writing, write this equation in balanced form. Now, the last method that we are going to discuss today for the preparation of amines is by Gabriel-Thermite reaction. By Gabriel-Thermite. So, by Gabriel-Thermite reaction. So, what is the Thermite? Please, you have to remember this structure. Thermite is this compound, C double bond O, C double bond O. Now, both these carbons are attached to nitrogen and it contains one hydrogen. Now, this is known as what? Thermite. Okay, this is Thermite. Now, why this is known as Thermite? Amide group is present. See, NH, C double bond O. C double bond O is attached to what? NH. Therefore, this is known as what? Amide group. Now, whenever this amide group is Thermite is treated with alcoholic KOH. Okay, alcoholic KOH. Then, how the reaction takes place? Please look at it. Alcoholic KOH. What will happen? This hydrogen and this OH will come out as water, therefore minus water. And since this is negative, this positive sign will go and get nearer to that particular nitrogen, which is negatively charged. C double bond O, C double bond O. Now here nitrogen is present, and here since it is negative, now potassium, which is positive charge, will come nearer to H. Now in the second reaction, whenever it is treated with alkyl halide, this is delta negative, as you know, this is delta positive. This negative sign will come and get bonded with this R group, and as a result, you have the second product, that is C double bond O, C double bond O, N, and here it is bonded with now R. And what is the byproduct? Byproduct is K and X. So plus KX. Okay? Now, if this product is further treated with 2 molecules of water, that means hydrolysis in presence of acidic medium, that is HCl. Now what will happen? This bond and this bond, both the bonds, C double bond O and this bond, and this C and N bond will break to give you 2 separate compounds now. This NR will be one compound, and this benzene ring along with C double bond O, C double bond O will be giving you another compound. Now please look at it very carefully how this reaction takes place. Since we are using 2 molecules of water, I am going to use 1 molecule. Here I am writing OH here. See, this is H2O. Now what will happen? This OH will go and get bonded with this carbon and this hydrogen. Now, since this bond is breaking, nitrogen's valency has to be maintained. Therefore, this hydrogen alone will go and get bonded with this nitrogen. This is for 1 molecule. We have used 2 molecules. Okay? Therefore, let's write for another water molecule. That is, I am writing this another water molecule here. HOH. Again here, similarly, this OH will go and get bonded with this carbon where C double bond O is present. Okay? Since this bond has broken now, nitrogen's valence is unfulfilled. Therefore, this hydrogen now will go and get bonded with this nitrogen. This is very, very simple. See, OH going and getting bonded with carbon, here also getting bonded with carbon. 1 hydrogen from this water molecule, 1 hydrogen from this water molecule will go and get bonded with this nitrogen. And here, as I told you, please don't forget, this bond is flipped now. And let's write the product now. That means here I will be getting benzene ring, and to it C double bond O was already attached. Now what has come? OH from water molecule, and OH from another water molecule has come to give you this product, this particular compound. And here you are left with NR, and 2 hydrogens has come here. Therefore, I can write it as what? RNH2, and this is now 1st degree amine. Okay? And this compound is known as what? Phthalic acid. Since COOH group is present, therefore it is known as what? Phthalic acid. So, phthalic acid. Now the beauty of this reaction is what? You know, this acid, okay, which is regenerated. See, after the reaction, it has been regenerated. Therefore, it can be again reused for this particular reaction again and again. Okay, so these were the different methods for the preparation of what? Amines. Hope this is clear. And in the next class, we'll be discussing more about amines. So till then, take care. Do keep in touch with your studies. Study properly and seriously. Thank you.